All right, the last thing that we're going to cover in organic chemistry for this quadmester is the hydrocarbon derivatives. So what do we mean by derivatives? Okay, so when we attach something onto one of these alkanes, alkenes, or alkynes, we call it a functional group. And so that's an arrangement of atoms that they're primarily responsible for the chemical behavior of the molecule. When a functional group is part of the hydrocarbon, the resulting compound we call a hydrocarbon derivative. And here is a summary of all the ones that we're going to be talking about. So we have primarily, starting with the alcohols. So the way this works here is we have a carbon chain of some sort. And so the carbon chain is abbreviated because it can be anything in any number of different lengths of carbons and that sort of thing. But as a general a generalization, we use the letter R. So the R represents some carbon chain, an alkene, or whatever. When there's a hydroxyl group attached on there, it becomes an alcohol. So an example of that would be ethanol, so CH3CH2OH. The next one is when there is a double bonded oxygen on the end carbon of the long carbon chain. Okay, then we have an aldehyde. Okay, and that's usually given as CH3CH2. Okay, the alcohol is given. We'll recognize it in the name because it's given the OL suffix. An aldehyde is given an AL suffix. If you have a double bonded oxygen somewhere in the middle, okay, so this is one carbon chain. The R1 here is another carbon chain. So somewhere in the middle of the really long carbon chain, there's a double bonded oxygen. Then we have what's called a ketone. Okay, still the hydroxyl group is attached, or say the carbonyl group is attached, and we call this, give it the ONE suffix. All right, and so this one here is called propanone. When the end carbon has both a double bonded oxygen and a hydroxyl group, we call this a carboxylic acid. And you guys are used to having seen this one, CH3COOH, okay, ethanoic acid, acetic acid. It's given the oic acid suffix. All right. When you have a carbon chain that's interrupted by an oxygen in the middle and then another carbon chain on the other end of the oxygen, that's called an ether. And so the way these are named is you take the longest chain and then the shortest chain. And the shortest chain becomes the attachment to the longest chain with the oxygen going with the shortest chain. All right, so this one here, because the CH3 is the shorter end, it becomes methoxy. And then the longer chain is the ethane, so methoxyethane. When we have the the ether group, but the carbon next to the oxygen has a double bonded oxygen to it, then we call that an ester. And they are given the endings OATE. And so in this case, we take the short end and the long end. The long end includes the carbon that's attached to the double bonded oxygen. In this case, there's only two carbon in this example. So this would be the methyl, okay, is the attachment, the prefix, and then the root would be the ethan, and the suffix is the O8, ethanoate. When you have nitrogens, so if the nitrogen is attached somewhere on the carbon, it becomes an amine. Okay, and the hydrogen the hydrogens attached to the nitrogen can be substituted with other carbon chains. I guess a little more complicated there. Maybe we might do some examples as we go through. We won't spend a whole lot of time on these. We just want to introduce them. They're primarily used in protein synthesis, that sort of thing. And so you'll see this a lot more in biology or biochem than you will in organic chem. But these are called, in this case, ethanamine. When the carbon that's next to the nitrogen has a double bonded oxygen on it as well, then it becomes an amide. Okay, and so this one here would be called ethanamide. All right, so the double bonded oxygen in the carbon atom as a functional group is called the carbonyl group. Aldehydes and ketones have the carbonyl group. So aldehydes have the carbonyl on the end carbon, and ketones have it on a carbon somewhere in the middle of the chain. The alcohols actually run into three categories because the alcohol can be either on the end carbon or somewhere in the middle. And so we have primary alcohols where the hydroxyl group is attached to the end carbon. Okay. We have secondary alcohols where the hydroxyl group is attached to a carbon which is attached to two other carbons. So somewhere in a long carbon chain. And if this carbon that the hydroxyl group is attached to has another branch on it, then it's a tertiary alcohol. So the carbon attached to the hydroxyl group is attached to three other carbons. Then, as in this case, then we have a tertiary alcohol. Amines, same sort of thing. They can be either primary or secondary or tertiary amines. Primary amines have only one carbon chain attached to the nitrogen because it's based on what's attached to the nitrogen, as in this case. The secondary amines have two carbon chains attached to the nitrogen. And the tertiary amines have three carbon chains attached to the nitrogen. All right, so as an exercise, generally in class I would ask you to take a look at this diagram, circle and name all the functional groups in this molecule. All right, so if we go through this together, this is what this exercise would look like. So let's start with this carbonyl group here on the end of this carbon chain. So this is an aldehyde in this case, the double bonded oxygen. We can use halogens as well. So in the case of the chlorine attached to this carbon chain, it would be chloro. A different alkane or a different halogen would be, let's say, fluoro or bromo or iodo or something like that. Here we have another carbonyl group. This time it's in the middle of this chain, so it's a ketone. Branches like what we talked about before, these are methyl groups, so we know these groups already from what we did previously with the alkanes. Again, we have a hydroxyl group here. So this, in this case, because this carbon that the hydroxyl is attached to two other carbons, it becomes a secondary alcohol. This one over here, it's on the end of this little branch, and so it's a primary alcohol. This branch here is an ethyl group. This oxygen is in the middle of this chain, so that's an ether. This nitrogen with two hydrogens on it is an amine. This oxygen in the middle of the chain with a double bonded oxygen next to it is an ester. And the alcohol with the double bonded oxygen next to it, on the carbon next to it, is a carboxyl group. to make carboxylic acid, obviously. Okay, and so this is another exercise that I often ask on tests and quizzes. Can you identify all of the functional groups? A compound like this, for various reasons, probably wouldn't exist in nature. We kind of draw this hypothetically simply to illustrate what all the functional groups are and ask you to name them and identify them. Coming up with a name for this compound, probably next to impossible. It would most likely be given, if it were possible, and I doubt it is, it would most likely be given some common name by whoever invented the compound, which quite often happens when they're doing biochemistry and discovering new compounds for different substances. Naming the derivatives. Okay, so let's take a little practice with alcohols. The hydroxyl group identifies the compound as an alcohol, and so the name will have the OL suffix. Carbons are numbered from the end closest to the hydroxyl group. So in this particular case, we would actually start numbering with this carbon. 1, 2, 3, 4, 5, 6, 7. So this is heptan 1-ol, because the hydroxyl group is on the number 1 carbon. Okay, another example. So in this case, 1, 2, 3, 4, 5 carbons. We start numbering at this one because that puts the hydroxyl group at the number 2 carbon. So this would be pentan 2-ol. This compound, same sort of thing. 1, 2, 3. So the hydroxyl group is on the 3rd carbon. We'll start numbering at this. 3, 4, 5, 6. So it's a hex. There's a methyl group on the 4th carbon. So it would be 4-methyl hexan 3-ol. Aldehydes, same idea, except this time, of course, the compound becomes an al. Remember, with aldehydes, the carbonyl group is always on the end of the chain. And so again, we start numbering here, 1, 2, 3, 4, 5. So this would be pentanal. This one here has an ethyl group on the 1, 2, 3rd carbon. Okay, there's 6 in the carbon chain, so it would be, this is an ethyl group, so 3-ethyl hexanal. We don't have to worry about numbering the al because, by definition, an aldehyde always has this carbonyl group on the end carbon. Okay. When we get to ketones, that carbonyl group moves into the middle of the chain somewhere. And so again, we start numbering from the end closest to the carbonyl, so that's this end here. 1, 2, 3, 4. The carbonyl group is on the 2nd carbon, and so this becomes butan 2-one. This carbon chain here as well, we start numbering from the left because it's closer to the carbonyl group. The carbonyl is on the 3rd carbon. There's a methyl group on the 4th carbon, so it would be 4-methyl. 1, 2, 3, 4, 5, 6, 7, 8. So 4-methyl octan 3-one, sorry. Carboxylic acids, again, these are always on the end of the carbon chain, and so it's an oic acid. So in this case, this is the 1st carbon, 2, 3, 4, 5, so this would be pentanoic acid. This has a methyl group on the 1, 2, 3, 4th carbon. There's 6 altogether, so this would be 4-methyl hexanoic acid. All right, the naming of esters consists of the shorter or less complicated chain with the oxygen being the functional group added to the longer chain. So as an example, you'll notice the left side of this oxygen has 3 carbons on it, the right side has 4, and so we would call this propoxy butane. In this one, the longer chain also has a branch. The longer chain is 1, 2, 3, 4, 5, 6 carbons long, with a methyl group on the second carbon. And the attachment on the oxygen on the other side is 3 carbons long. So this would be in alphabetical order again, remember. So this would be 2 methyl, 1 propoxy hexane. When we get to esters, esters are actually formed by the reaction of a carboxylic acid with an alcohol, and often called a dehydration reaction because water comes off as a result. In the case of esters, the longest carbon chain that contains the carbonyl group is the root. The prefix will be what is attached to the middle oxygen, and the suffix will be the O8. So the way this works, here's an example. The attachment here, so the root is this, starting at the carbon with the double bond on it. So there's carbon 1, 2, 3, 4, 5 carbons. So it's going to be a pentanoate, and attached to that is a 2 carbon chain, and so this becomes ethyl pentanoate. Okay. This oxygen now, rather than being kind of an attachment as it was with the ethers, it's actually part of the carbon double bond oxygen to the oxygen. This whole thing becomes actually the essence of this particular compound. Okay, and that's incorporated into the O8 suffix. All right. Amines contain some sort of a nitrogen, and that nitrogen can have things attached to it, or it can just have hydrogens. The longest carbon chain is attached to the nitrogen is the root. The carbons of the longest chain are numbered from the end closest to the nitrogen. Any other carbon chains on the nitrogen will be part of a prefix with an N that indicates attached to the nitrogen. Any other carbon chains would also be then considered the same way as they would in the alkanes. So here's an example. So we have attached to this nitrogen this really long carbon chain here. Also attached to the nitrogen we have this 2 carbon, so an ethyl group. And then on the carbon that's attached to the nitrogen we also have a branch, so a propyl branch. Now, there's a couple of ways we could call this a major carbon chain, but what is preferred here is to use this nitrogen group as an actual branch that's attached to this long carbon chain. So the long carbon chain, if we because the nitrogen is here, this end is closer, so we start numbering here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Makes that a 10 carbon chain, hence the deck. The nitrogen group is attached to the 4th carbon there. And so then the ethyl group is attached to the nitrogen, so then the N-ethyl. And then decan-4-amine. All right, this one here has the longest carbon chain is actually this one here. The nitrogen is on the 2nd carbon. So 1, 2, 3, 4, 5. So it's a pentan-2-amine. But on the nitrogen itself, there's 2 ethyl groups. So it would be NN-diethyl pentan-2-amine. Amides, again, the root is based on the longest carbon chain that includes the carbonyl group. This will be the number 1 carbon of the root, and the nitrogen is dealt with in a similar fashion to the amines. Suffix is the amide. All right, so in this particular case, we've got the this is the number 1 carbon, 2, 3, 4, 5 carbons long. So it's a pentanamide. The nitrogen has an ethyl group on it, so it's N-ethyl pentanamide. All right, lots of homework questions in the textbook on the naming of these compounds, so here they all are. You'll notice they go back to some of the previous pages that we've skipped over before. Practice. This is, as I said, a whole other nomenclature. Make sure that you spend lots of time practicing these.